Okay, so you're given the following cubic function and you're expected to find these 2 points. So these are what's known as critical points. Now to find them is actually fairly simple. Let me show you. Okay, so that function was f of x is equal to x cubed plus 4x plus 4x plus 4x squared plus 4x plus 7. Okay, so how do we find these points? Well, this is what we can do. We can find the critical points by deriving the function. Okay, so let's derive it once. So f prime of x is going to be 3x squared plus 8x plus 4. Okay, well, what do we do now? Now that we've solved or we derived this function, we can simply set y to 0. Okay, f prime of y we set to 0, and then we solve for x. Okay, so I'm going to solve x. Now again, we're going back to basic algebra, where we have x sub 1, 2 is equal to negative b plus minus the square root of b squared minus 4ac over 2a. This gives me negative 8 plus minus the square root. Let's solve for 2b. That's going to be 64 minus 4 times 4 is what? 16. 16 times 3 is 64, so it's 0. Okay. Anyway, let's just add these values in here, and I'm gonna sometimes I don't trust my quick math, so it's fine. 3, and we're going to place this over 2a. That is 0, man. 2a is 3. Okay, so we have, let's go over to Desmos. Let's duplicate this one. Then we go to Desmos, graphic scientific calculator. So let's put in what we got. We got fraction negative 8 plus the square root of 8 squared minus 4. A was 4, 3 over 2 times 3, right? Let's have a look. 2 times 3. We have... Okay, so our first answer was negative 6666667. Okay, so this is going to be my first answer. Let's leave it as a fraction then. So the first x that I got was negative 2 over 3. Okay. What about the second x? Second x, I make a minus, I get negative 2. Okay. So my x sub 1 is negative 3. X sub 2 is negative 2. Let's go see if this makes sense first on my function. Okay. So look at this. There's my 1x I found, okay? If I put this in a fraction, it's negative 2 over 3. My second x I found is negative 2. So these both make perfect sense. The highest point will be your local maximum. The lowest point is your local minimum. But more about that in another video. Let's focus on these points now. Okay. So we just solved negative 2 and negative 2 over 3. Okay. So what does this mean? Well, this means now that I'm going to now substitute these x's I solved from the derived version into my function. So what does that mean? That means negative 2 to the third plus 4 negative 2 squared plus 4 negative 2 plus 7. Okay. Well, based on this function, this should give me negative 7. Let's see if it works out. Okay, this one is negative 8. This one is 16 plus 16. This one's minus negative 8. This one and this one cancels out this one, so we're left with 7. So we do in fact know this one's true. Let's look at the next one. The next one I'm going to use a calculator. Okay, so let's substitute this with negative 2 over 3. Let's have a look. 5.814. Let's go back to our look at that. Look at that. 5.815. So they rounded it off. Whoo! Let's go. Okay. So, what did we just learn? Might have seen all over the place. But let's put the steps down here. Step 1. Find f of x. Step 2. dy over dx. Derive f of x. Okay. Step 3. Solve x. And then step 4. Place x into f of x. That's all you do. This is how you find critical points, okay? So let me run over this one more time. Look at this. So here we have f of x. We derived f of x. After that, we solved for x using the quadratic formula. After that, I substituted it into my f of x. Okay? And then I found my critical points on this function. And there's the proof. The proof is in the pudding, ladies and gentlemen. All right, listen to me. You guys have a lovely evening, all right? Take care, everybody. Bye-bye.